A very good evening to all of you. Welcome back to my channel. This is Shivam Shukla and here I am to solve a problem on engineering mechanics. It's a problem on resultant of parallel force system. Type 1 problem to find the resultant force and locate it with respect to a point in the system. Let's see how the question statement goes. Determine the resultant of the parallel force system shown in figure and locate it with respect to O. Radius of circle is 1 meter. You can see there is a circle on which four forces are acting. All are parallel to the horizontal axis. That is why it's a parallel force system. Now let us see how the problem can be solved. Okay, let's draw the FBD and let's proceed with the problem. First and foremost, I'll be writing what are we supposed to find. So to find is nothing but R and the perpendicular distance D. Now step number 1 is to draw the FBD. Step 1, draw free body diagram, that is FBD. Okay, so let's proceed with it, my dear friends. So as you can see, I'll be drawing the axis line first. Okay, even this is the horizontal axis. This is the arrow, this is the arrow over here. Now I'll be constructing a circle. Okay, one by one let me show the forces which are acting. So this is the first force of 100 Newton. This is the second force of 50 Newton, 50 Newton, 100 Newton. Again, there is a force of 50 Newton over here, 150 Newton and 80 Newton. So over here is 150 Newton and 80 Newton. 150 Newton and again 80 Newton. Okay. So once I'm done, let me show the angles of it, of all the forces one by one. The angles are given very specifically. This is 60 degree, 45 degrees, 30 degrees and 30 degrees over here. Yes, you can just check back the question. Question diagram 60 degree, 45, 30 and 30. So friends, only this particular point which I didn't name it earlier, I'll be naming it now. It is the point O. Okay. So here is the questions diagram that I have drawn. Let me draw a separate diagram over here that will be requiring it at the end. So that will be somewhat like this. Comparatively, it is a bigger one, like this. Okay. Same way, I'll be showing the forces. This is 100 Newton, 100 Newton. By principle of transmissibility of force, I am transferring every force just on the vertical axis so that it becomes easier for me during the calculation time while I apply the Varignon's theorem to find the distance. This is 150 Newton. Okay. Now my dear friends, let us go for the solution of this. Step number 2. I'll write it. Step number 1 is done. So step 2, solution. Before that I write step 2. Step 2 is nothing but, since it's a horizontal force system, all the forces acting in horizontal direction, that means it's a parallel force system. R is equal to summation Fx. Therefore, R is equal to summation Fx towards the right as positive that we will be taking is equal to minus 100 minus 50 plus 150 minus 80. So it is equal to minus 80. That is, R is equal to 80 Newton acting towards the left hand side. Now let us go for the next part. location of resultant. We got the value of r. Now I will be taking nothing but the step number 3. So step 3 is nothing but location of resultant. Location of r. So I'll be taking now, let r be located at a perpendicular distance small d above O. Since it's a horizontal force, so we got the value of R as this. It is acting towards left hand side, so it may be lying above O or on O or below O. We have started with an assumption that let the resultant R is located at a perpendicular distance d above the point O. Okay, so let's go ahead with the calculation, my friends. Here there is a catch. By Varignon's theorem, summation of moment of forces about O is equal to moment of resultant about the same point O acting in clockwise sense is positive. Friends, many of the students, they do generally get confused that since we have seen this for all the forces for 100, 80, 50 and 150, we know the radius of the circle is 1 meter, but the radius of the circle is not the perpendicular distance. That's why, my dear friends, what have we done is we have extended all these forces on the vertical axis. We have extended each and every one of them. We have extended them like this. We have extended them like this, so that we could get this vertical perpendicular distances. So now how do we get this? That is why we have taken all these forces on the vertical axis over here like this. So now we will be requiring the perpendicular distance of every force, so that we will be writing it over here. The calculation of that we will be doing it separately. So friends, let us just do the calculation of those vertical forces. For example, just let me show it to you over here. If I do consider this particular right angled triangle, first one, so this is the perpendicular distance that I want. For the other one, this is the perpendicular distance that I want. For the this one, this is the perpendicular distance. Even for this is the perpendicular distance. For both of them, the perpendicular distances are going to be the same because the angles are same. So now, my dear friends, for this particular triangle, I will be writing it down. First one, for 100 Newton force, it will be for 100 Newton. I will be writing sine of 60, sine theta is opposite that we want by hypotenuse, opposite divided by hypotenuse. So therefore opposite is equal to 1 sine 1 into sine 60. Same way, let's go further. For 50 Newton, for a force of 50 Newton, we will be writing sine of 45 is equal to again opposite divided by hypotenuse, that is 1. So therefore opposite that we want is equal to 1 into sine of 45. Very easily it comes. Last but not the least, similarly for 80 Newton force and 150 Newton, let me say directly, I can write it down, my dear friends. Opposite side will be what? You can tell the answer in a better way. It will be 1 into sine of 30. 1 into sine of 30. Now very easily I can apply the values over here, my dear friends. And since we have considered the resultant at a perpendicular distance d above O, let me show it very specifically. We have assumed it like this: r above at a distance, let me show this as the distance d of resultant. For here, if I show it over here, this will be the resultant r, and that will be shown at a perpendicular distance small d. This is the distance of resultant small d. We have assumed it. So let us write down the equation, my dear friends. So by Varignon's theorem, we are supposed to just assume ourselves that we are sitting at point O, and with respect to O, consider every force how it is causing the body to rotate, 100 Newton is causing the body to rotate in anti-clockwise sense, my dear friends. So it will be minus 100 into its perpendicular distance is 1 sine 60. Same way, 50 Newton is causing the body to rotate in clockwise sense. So 50 into 1 sine of 45. Same way, if I go ahead with the forces of 150 and 80, so 150 again, it is causing the body to rotate in anti-clockwise sense, minus 150 into 1 sine of 30. Same way, minus 80 into 1 sine of 30 is equal to, same way my dear friends, resultant is causing the body to rotate in anti-clockwise sense, that is minus 80. It is not the reason that it is acting towards left, that's why it is taken as negative, but with respect to O, R is causing the body to rotate in anti-clockwise sense, that is why it is taken as negative. Our main intention is we have considered clockwise sense direction as positive, so minus 80 into D. So friends, let us get the value of this, so that finally we will be in a position to get the value of D over here. I'll be writing it over here, my dear friends. This was minus 80. So therefore D is equal to, let us do the calculation for this, for the same, my dear friends. Minus 100 into 1 sine 60 plus 50 into 1 sine 45. So it is over here minus of 100 into sine 60, same way, is equal to plus 50 into sine 45 plus 50 sine of 45 is equal to, one more, minus 150 sine 30 minus 150 sine of 30 is equal to, last but not the least, minus 80 into sine 30, minus 80 minus of 80 sine 30. Okay, so we are done with this. So minus 166.247 divided by, what is the value of R, is nothing but minus 80. So minus 80 we have taken over there, is equal to 2.078. My dear friends, it is very confirmed that yes, it is lying above O. So D is equal to plus 2.078 meter. So now I can write it down at the end, my dear friends, over here. Just this thing, I'll be raising it. For this, I'll be writing now. Finally, therefore, R is equal to 80 Newton at D is equal to 2.078 meter, located at D is equal to 2.078 meter above O. Friends, how the marks are going to get distributed for this particular problem is nothing but, this comes for 4 marks in the university paper. Basically, R is given with 2 marks along with the calculation, of course. So this entire calculation will be given 1 mark of Warrington's theorem, 1 mark for the final value. Sorry, R will be given as 1 mark, and these two diagrams, the FBD definitely is given 1 mark, definitely, along with the calculation part. So friends, this is how the problem gets completed. Please do like, subscribe and share this video. Thank you for watching.